Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 4.8 entitled Functions and Relations. And today we're going to look at 4 objectives. We're going to decide whether or not a relation is a function. We're going to state the domain and the range of a relation or a function. We're going to use the vertical line test to determine if a graph represents a function. And then we're going to evaluate a function that's written in function notation for a specific value. So first we need to talk about what a relation is. And a relation is just a set or a group of ordered pairs. And usually the ordered pairs will all be listed and they'll all be inside big, curly, squiggly brackets. Now, sometimes that relation has a special relationship, which classifies it as a function. So we'll talk about that in a moment. But regardless of whether or not a relation is a function or not, it still has a domain and a range. The domain is all of the input values, so that's all of the x's. So in my example from up here, my domain would be -3, -4, -5, and -6. Those are all the x values. And then the range is all of the output, or all the y values. So from that example written up above, that would be 1, 0, -1, and -2. Now, if any of the values repeat, you don't have to write them more than once, but it is good to write them in order. Now, a function is a special type of relation where every element in the domain is paired with exactly one element in the range. And we've talked about functions before. In a previous chapter, we were introduced to them, and we talked about how one domain value cannot have two different range values. And we talked about it in terms of a vending machine or a pop machine. So the domain value is kind of like the button that you push, and the range value is kind of like the pop that you get out. So you can't have one button where you push it and get Pepsi, and then that same button that you push again and you get a Mountain Dew. That means that the pop machine wasn't stocked properly. It's not functioning the way it's supposed to. And that also means that that's not a actual function. So the best way to remember that is that there can be no repetition in the domain values. So if you're looking at a table of values, you can't have any repetition in the x or the domain values. So just a couple examples before we go over some official examples. You could have a function that's 1, 2, 3, 4, and then 5, 6, 7, 8. So every value in the domain has a separate different value in the range. So that's a function. You could also have a function where every domain value has the exact same range. That's possible. That's like saying 4 people have the same birthday, or having 4 buttons that all give you the same type of pop. That's possible. Those are functions. What's not a function is when you have a repetition in your x column, where you might have a 1, 1, 2, 3. And so then the 1 gives you a 4 and the 1 gives you a 5. That's not possible. That's one button giving you a 4 and then that same button giving you a 5. That can't happen. Numerically, if you have an equation, like even if the equation was y equals x plus 3, if you put a 1 in there, 1 plus 3 is 4. If you put the 1 in there again, you can't do 1 plus 3 and get 5. That's not mathematically possible. So that's not a function. And that was just an example. That might not be the actual function for that table there. Okay, so let's look at some official examples now and see if we can determine whether or not these are indeed functions. So determine whether the function is a relation. If it is a function, give the domain and the range. So for part A here, we have 3, 5, 6, and 4. So they're a little out of order, but that's okay. And then we have 5, 7, 4, and 9. So basically, if you're just looking at your x values or your input values, is there any repetition? And here there's not. So yes, this is going to be a function. And my domain then would be 3, 4, 5, 6. I'm going to put them in order. 3, 4, 5, 6. And then my range would be 4, 5, 7, and 9. Okay? For part B, if I look at my input or column in the table or my x values, notice I have a 1 and a 1. And that 1 gives me a 4, and then I put that 1 back in and it gives me a 7. No, that's not possible. That's not a function. And for part C, again, I'm going to look at that input column. And here I see some repetition. I see a 2 and a 2. And the 2's giving me a 6, and then the 2's giving me an 8. No, not possible. And then in part D, oh, again, I have repetition. I have a 3 giving me a 5 and a 3 giving me a 2. No, those aren't functions. So you're going to see some problems like this on your homework where they're going to give you the table of values and you have to state whether or not they are functions. Now, another way to check and see if a relation is a function is to do the vertical line test. And this works on graphs. And the vertical line test is where you draw a vertical line through the graph. And if that vertical line touches the graph only at one point, then it represents a function. So that vertical line cannot touch the graph at more than one point. So let me draw some functions here. Let me draw them in like a cool, funky pen style here. And we've got that one, and then we've got this one, and then let's do this one. There we go. So again, in your homework, you're going to see some problems like this where they want you to take a look at the graph and determine if it's a function. So all you have to do is draw a vertical line through it. And that vertical line only touches my graph one time. Now I can draw that vertical line anywhere on my graph. It doesn't matter where I draw it, I only touch the graph one time. So yes, this is a function. That means that I won't have any repeated values or any repetition in my x column, and if I had a table of values. Okay. And then for part B, again, draw a vertical line. And again, it doesn't matter where you draw that vertical line, but wherever I draw it, I'm not going to touch the graph more than one time. So yes, this is also a function. Part C, this one's going to be a problem. If I draw my line, I touch the graph 2 times. I touch it there and there. So this is not going to be a function. And I can put that line in lots of places and still not pass the vertical line test. Now sometimes students say, what if I drew the vertical line right on the edge and I like barely touch the graph at this one little point right there at the end? And I say, okay, for that one spot, it passes the vertical line test. But if you fail the vertical line test anywhere in the graph, you fail it for the whole graph. So you could have a function that passes 100 times, but if in one spot it fails, then it fails for the whole graph. Okay, now our last concept is function notation. And this is meant to be nice, meant to be easy, but it looks intimidating. It's more advanced in the way that they're writing the function. And all they're going to do for function notation is they're going to take the y that's out front of the equation. Here we have an equation in slope-intercept form. Y equals 2x plus 1. My slope is 2. My intercept is 0, 1. Okay? They're just going to rewrite that and replace the y with an f of x. Now, it looks like f times x because it's f parentheses x, but really we read that f of x. And that just tells me that this x is going to be the variable that I'm going to see in my equation. So anytime I want to put a value into this function, I would put that value in for the x. So that x now is kind of like a little placeholder, basically. So in example 3, they want us to evaluate some functions that have been written in function notation. So for part A, here's my function. F of x equals 7 minus 3x. Okay, so this f of x was originally a y, and then somebody came along and tested it to see if it was a function, and they did, and it passed. And so instead of writing y equals, they're going to write f of x. It's kind of like it's been upgraded. Okay, it's not flying in coach on a plane anymore. It's been upgraded to first class. Okay, now they want us to evaluate this when x is equal to 4. So that means I'm going to substitute 4 into the function. And I'm going to substitute it in wherever I see the x. So I'm going to substitute it into the notation and into the actual function. So I'm going to write f of 4 equals 7 minus 3 times 4. Now really, this f of 4, I'm not taking f times 4. This is just notation now. So if you want to kind of ignore that and then just work through the right side of the equation, that's totally fine. So we're going to have 7 minus 12, and then 7 minus 12 is negative 5. So f of 4 is negative 5. So negative 5 is your answer. You evaluated the function. And what that means is when you put 4 into the function, you get negative 5 out. So that ordered pair, 4, negative 5, is on the graph of that line. That's what that means. For part B, we're going to do the same thing, except this has a g of x equals negative 4x minus 12. G of x is just another type of function notation that they use. If they have two graphs on the same plane, they can't call them both f. They have to call one f and one g. And you might see h of x as well. So f and g and h, those are very common variables that are used for function notation. But it doesn't matter what letters out front. It's still a function. Somebody came along and tested it with the vertical line test. They looked at the x values in the table of values. They didn't find any repetition, so they said, we're going to upgrade this guy. He's not just an equation anymore. He's a function. Okay? So that's all that that function notation means. But we're still going to evaluate him when x is negative 3. So that means I'm going to put the negative 3 in here and in here. So I'll have g of negative 3 equals negative 4 times negative 3 minus 12. Now again, this g of negative 3, that's just notation. I'm not really doing negative 3 times g. So just ignore that and work on the right side of the equation. So using order of operations, I'm going to multiply negative 4 times negative 3. So that's going to get me 12. Negative times negative is a positive. And then I'm going to, oops, not add 12, sorry. I'm going to subtract 12. Let me get rid of that little scribble there because it kind of looks like a times. Okay, so it's 12 minus 12, which will be 0. So that means g of negative 3 is 0. So that's your answer when you evaluate the function. And again, what that means is if you put -3 into the function, you get 0 out. So the ordered pair, -3, 0, is on the graph of that line. Now, our final concept is also in function notation, but they want you to graph the function. Now, don't be overwhelmed by this. This is still just slope-intercept form. It's still just y equals mx plus b. Y equals mx plus b. Okay, but again, instead of this being written with y equals, they wrote it as a function, g of x. So again, that just means that when we graph it, it'll pass the vertical line test. So I'm still going to look at the right side of my equation here. I'm going to write down that my slope is -3, or -3 over 1. My y-intercept is going to be 0, 2. So this is just like what we did the other day when we were graphing in slope-intercept form. So I'm going to plot my intercept, 0, 2, and then I'm going to move according to my slope. I'm going to go down 3 and over 1 to the right. Down 3 and over 1 to the right. And again, that's all the points you need. If you want to make more, you can, but you just need at least 3 points to make your line. There you go. You graph the function. And again, if we did the vertical line test and put a vertical line through that graph, no matter where we put that vertical line, it would pass the vertical line test. Okay? So since it's written in function notation, that just means that somebody has already done that for us. So when you're graphing something in function notation, just think of it like slope-intercept form. Now, there's a lot of little concepts that we talked about today, and they're important concepts. Functions are a whole big part of mathematics. So definitely practice these problems, and if you have any questions, come on in and see me before school.